Hello grade 11s, welcome back. We are today looking at number patterns, sequences and series. If you just joined us, you've missed out, all right? But remember, you can always go back and watch this again online. We are talking about revision of linear sequences and quadratic sequences. Those are the ones that you really deal with in grade 11. Let's have a look at the next question. This is question 4. So here we are given the sequence, as you see on your screen, minus 15, minus 11, minus 7, and it goes all the way up to term with the value of 173. All right, so we are asked to determine the equation for the general term. Let's just think about this for a second. We've got these terms. We don't know what type of sequence this is. It could be linear, it could be quadratic. So we have to do a little bit of an investigation to see what type of sequence we are dealing with. How do we do that investigation? Well, we start by finding the first difference. So it could be quadratic, it could be linear, we don't know. But the only way to find out is to work out what the first difference is. And if it's constant, then obviously we know this is a linear sequence. If it's not constant, it could perhaps be a quadratic sequence. Remember, in a linear sequence, you have a common difference, which is given by any two consecutive terms in the sequence. It doesn't have to be term 3 in term 2 and term 1 in term 2. It can be any terms in the sequence. So the common difference will be given by term 3 minus term 2, and that should be the same as term 2 minus term 1. So let's have a look and see what our common difference is here. So term 3 is minus 7 minus term 2, which is negative 11. So we get minus 7 plus 11, which is 4. Okay, let's check term 2 minus term 1. So term 2 is minus 11 minus term 1, which is 15, negative 15. So minus 11, minus times a minus is a plus. 15 minus 11 is 4. So we see, okay, we've got a common difference of 4. So therefore it means that this sequence must be linear. All right, so we've got a common difference. We know the sequence is linear. Now we need to determine the equation for the general term. How do we do this? So if you watch the session where we were going over how to find the general term of a linear sequence, you will realize that what you need to do is you need to find a formula that's going to relate the value of the term with, or the position of the term with the common difference and with the value of the term. We use those three things and we combine them to work out the general term. How do we do it? Let's have a look. So we know that the first term here is negative 15, and then that was followed by negative 11, and we had negative 7. We've already discovered that the common difference is 4. All right, so let's see how we relate. So this is in position 1, so this is now n. n is equal to 1, n is equal to 2, and n is equal to 3. So term 1, which is equal to negative 15, is equal to negative 15 plus 0 times a common difference of 4. Okay, because minus 15 plus 0 is negative 15. We can rewrite that as minus 15 plus 1 minus 1 times 4. So I'm just finding a way to rewrite the 0 to get this general term, to get this, this general term out. We want to see what the pattern is. Okay, so that's term 1. Let's have a look at term 2. So term 2 is minus 11. And we know that minus 11 is the same as saying minus 15 plus 4. Minus 15 plus 4 will give me negative 11. So it's the same as saying 1 times 4. But we can relate this 1 to the position in which negative 11 is, which is in position 2. How do we do that? We say that 1 can be rewritten as 2 minus 1. All right, so far what we're seeing is that we can rewrite the terms as the value of A, which is negative 15, plus the position that they're in, minus 1, and then times it by the common difference of 4. And that, in fact, is the general term. So Tn is equal to negative 15 plus n minus 1 times 4. All right, we can simplify this a little bit further by timesing the 4 into the bracket. So we get minus 15 plus 4n minus 4. And that will give us 4n minus 19. Now, what I always like to do when I have this general term is just to do a quick check and let's see if it makes sense and that the answer works. So say I wanted term 3, I would substitute 3 in place of n, and I will get 12. 4 times 3 is 12 minus 19, which is negative 7. All right, so it works. Okay, so we know our formula for the general term is correct, and it's given by 4n minus 19. Okay, perfect. Then they say calculate how many terms there are in the sequence. Now, what are they asking you to find? Well, you know that this sequence goes all the way to 173. So that's the last term in the sequence. We need to find out how many terms it takes to get from negative 15 all the way to 173. How many terms is that? How many terms are there in total in the sequence? So in other words, you know that Tn is equal to 173. All right, we need to work out the value of n. How do we do that? Well, we knew that the general term is given by 4n minus 19. And Tn now we say is 173, so we can say 4n minus 19 is equal to 173. Therefore, 4n will be equal to 173 plus 19. And that would be, is that 192? Let's just double check that to make sure. 173 plus 19 is 192, and then we're going to divide that by 4. So we get that n is equal to 48. So in other words, there are 48 terms in the sequence, all right, to get from minus 15 to 173. Or we can say that in position 48, the term value is 173. All right, guys, now what's important is when you start working out values for n, you need to remember that n is a number of things. It's a position. So it cannot be negative and it cannot be a fraction. So if you get an answer for n that's a fraction or that's negative, you need to disregard that one. All right. Okay. Let's have a look at the next question. So here we have a quadratic sequence which has a second term equal to 1, a third term is minus 6, and a fourth term is equal to negative 14. So let's set this sequence up before we carry on. So there's a term here in position 1 and we don't know what its value is. But term 2 is 1 and term 3 is negative 6. While the fourth term is negative 14. Okay, so that's what our sequence is looking at. Let's see what the question says. Determine the second difference for the sequence. Now, do you have enough information to work that out? Remember, the way you work out the second difference is you have to first find the first differences, and then you take the differences of those terms, and that will give you your second difference. So obviously we can't really work with term 1 because we don't know what that first difference is. So it's going to be difficult to work it out just from what we've got here. So let's try and work with the other 3 and see how we go with that. So if I look at term 3 minus term 2, so minus 6 minus 1, I will get minus 7. And then minus 14 minus 6, that's going to give me, so this is what I'm saying, term 4 minus term 3. We use brackets to make sure our signs are correct. Minus 14 plus 6 is negative 8. All right, so now I can work out the difference between those. So I can say, well, minus 8 minus 7 will give me the second difference. Minus 8 plus 7 is negative 1, so therefore my second difference is negative 1. Remember that in a quadratic sequence, this second difference is constant. So it means the second difference between the other terms in that sequence of first differences is also going to be minus 1. So we can work recursively. In other words, work backwards with the sequence like this. So we know, okay, well, the difference between minus 7 and minus 8 was negative 1. So to go backwards and get, well, what is now in this position here, so I can work out term 1, I know that the difference between there and there should also be negative 1. So therefore, if I say minus 7 minus minus 1, so it becomes minus 7 plus 1, I will see that this value here is negative 6. All right, so if this is negative 6, I now work backwards from term 2, and I see that I need to say, so let's just look at the other one. So to get to the value of 1, I'd say minus 6 minus minus 7, and that will give me positive 1 because we're working recursively. We're working backwards now. So now I've got to say 1 minus minus 6, so it becomes 1 plus 6, and this term in position 1 is 7. Okay, so let's see if this makes sense. Well, if term 1 is 7, then 1 minus 7 certainly is negative 6. Negative 6 minus 1 will give me negative 7, and the sequence continues in order. So we know that that in fact is the correct value for term 1. It must be 7, just using the fact of that constant difference of minus 1. Hence or otherwise, calculate the first term of the pattern. Well, that's just what we've done now. And we could even go on to then find out the general term of this quadratic sequence. We are not going to have time to do that right now, but I've given you enough information for you to be able to go and try it. Because you've got the second difference, you've got the first term, you've got the first difference, you've got the first term in the first difference, you can go and work out your general term for this quadratic sequence. You go ahead and try that. Until next time, guys, we've come to the end of the lesson. Cheers.